All right, students, today we're going to work on lesson 1-7 in your books. I need you to tear out pages 51 through 55. We're going to be working on those in the video today. And something you need to always remember is, if I'm writing, you should be writing. If I work a problem, that problem should be worked on your paper. Don't forget to do that. So teachers, pause the video for a moment and have the students get their papers tore out of their book and be ready to go. Okay, if you notice, the lesson is about solving problems with rational numbers. And the I can statement is to solve multi-step problems with fractions and decimals. So we're going to talk about what a rational number is, and we're going to talk about this word right here that says multi-step. Multi, the prefix multi, means many. Means more than one or two. So it's going to have 2 or 3 or 4 steps to solving the problem. The first thing we're going to talk about, though, is what does the word rational mean? So, what is a rational number? The answer is anything that already is or could be written as a fraction. So here are some examples. The example of 2/3, that's a fraction. The whole number 2 can be written over 1, so that's a fraction. A mixed number, 1 1/3, can be written as 4/5. 3 times 1 is 3, plus 1 is 4, so that's 4/5. That's written as a fraction. 2/10 is a decimal, but it can be written as 2/10. 2/10 reduces to 1/5. That is also a fraction. So, bottom line is, rational means fractional. When they use the word rational or say anything about something being rational, there's going to be fractions in it somewhere. So take a moment, teachers, and get this little note on your board somewhere or written at the top of the board so they can remember. And every time you say rational means what, your student should answer fractional. Rational means fractional. All right, we're going to go to page 51 and we're going to look at this, explain it. It says, Jenna feeds her cat twice a day. She gives her cat 3/4 can of cat food each time. So not quite a full can of feed. She only gives it 3/4 of 1 can. Jenna is having a friend take care of her cat for 5 days. To prepare, she bought 8 cans of cat food. Did she buy enough cat food? So, we've got to pick out the important things in this problem. And first of all, we need to know if she feeds 3/4 of a can twice a day, then I need to know what she's feeding in a whole day. And there's many ways we can go about doing this. We could take 3/4 and we could add 2 of them together for 1 day, 2 more for the second day, 2 more for the third day, and we could do this for each day till we figured it out that way. Or we could just figure out how many 3/4 divisions there are in 8 cans. So this first question down here says, what do you need to know before you can answer the question? Okay? So, in my mind, I'm thinking, how many 3/4 are in 8 cans? 8 whole cans. Well, in order to do that mathematically, I need to take the whole number 8 and I need to divide it by 3/4. And that's going to give me my answer over here. I'll put a question mark there for that. Now, just recently, your teachers have taught you, or you learned it from one of my videos, that there's a rule for division of fractions. And you're saying to me, well, that's a fraction, but that is not. Well, I can make it into a fraction by writing it over 1. And I have not changed the value of it one bit. So, you should have learned something in the last few days that sounds like keep, change, flip. So you're going to keep the first fraction you're going to change division to multiplication, and you're going to flip the second fraction. Keep, change, flip. Keep, change, flip. It's almost like Kentucky Fried Chicken, only it's Kentucky Chicken Fried. Okay? Just a joke there. Now, my rule for multiplying fractions is top to top, bottom to bottom, cancel if you can. Well, I see a 3 down here, and it's a prime number, and I don't see any number in the numerator that 3 would divide into. So there's nothing that's going to cancel. So 8 times 4 is 32, and 3 times 1 is 3. Now I need to know, what is 32 thirds? That means, what is 32 divided by 3? What is 32 divided by 3? Well, 3 goes into 3 one time, so 1 times 3 is 3. Draw a line, bring down a 2. Well, 3 won't go into 2, so I put a 0 there. And remember, there's always a decimal at the end of a number. Okay? So now I can I can annex a 0 and bring that down. And 3 times 8 is 20. Yes? Okay. So what did we actually find there? Okay, so if we think about that, we have almost 11, and this would be feedings. So this is how many feedings those 8 cans will do. Now, if you go back up and look at the problem, she's going to feed the cat twice a day for 5 days. So 2 times 5 equals 10. That's 10 feedings. Okay? And when we did this, we ended up with a little more than 10 feedings. Okay? So, does she have enough cat food to feed the cat? I say yes. She has a little more. Now, over here on this problem, Part B, how can you determine which operations to use to solve the problem? Well, we had 8 whole cans, and we needed to divide that up in 3/4 cups. 3/4 for the morning, 3/4 for night. Next morning, 3/4 of a cup, 3/4 for the night. We had to do that same thing every day. Okay? And we had to do that for 5 days. So twice a day for 5 days. Now, if the person doing the feeding feeds the correct amount, they will have enough to go a little more than 10 feedings. Okay? So, we use division to take the total feed and calculate. That's what we do when we're doing math. We're calculate the number of feedings. We also used multiplication to see how many times to feed in 5 days. So we use division and multiplication to solve this problem. Okay? Now, if you look at focus on math practices down here, to find out whether she has enough cat food, Jenna multiplies, divides, and compares. And we did all that. We multiplied to find the number of feedings. We divided to see if we had enough. Then we compared. Explain how Jenna may have solved the problem. Well, if Jenna does not know how to do her math, but she knows that in the kitchen there is a measuring cup that holds 3/4. So, she could go in there and get the measuring cup, and she could measure out 3/4 and call that, let's say this is Monday, Tuesday, Wednesday, Thursday, Friday. This is Monday morning. And then she could measure another 3/4 for Monday night. and then another 3/4 for Tuesday morning, and then we need one for Tuesday night. And she could go through and do all that measuring out, and she's going to have to do that 10 times. She could measure out 10 3/4 cups. Now, I don't know about you, but that cat food's going to dry out because she's already got it out, and it's going to be a mess because it's all measured out like that. If she could just open 2 cans a day and get all that she needs for one day and not open all 8 cans. So knowing how to do the math is much better. Turn your paper over. And y'all don't know me very well, but I'm into horses and I ride, so I like this problem because it has to do with building an arena. So I'm not going to skip this problem because I like it. A farmer is building a small horse riding arena. The fencing around the arena, that is called perimeter. Okay, we're going to go around this arena. Is built using 3 rows of wood planks. So on this side right here, there's 3 rows of planks on that fence. And here and here and here is the same. The farmer decided to use wood planks that are 8.5 feet long. So that's something we're going to need to know. So he ordered 130 8.5 feet long planks from a local lumberyard. Did he order enough? Well, before we begin, let's figure out how many feet it takes to go around at one time. Well, let's see. If it's 120.5 feet on this side, it's 120.5 feet on this side. If the width is 66 1/4, then it's 66 1/4 over here also. So, I need to find the perimeter. Perimeter is equal to 2 of the lengths plus 2 of the widths. And that's probably a formula you've heard before. If not, it's time you know it. So I'm going to take and I'm going to add 2 lengths. So 2 times the length is 120.5, and I'm going to just use a decimal there, plus 2 widths, so that's 2 times 66.25. Now, if you don't know that a half is 0.5, you should. It's time, because a half a dollar is 50 cents, so that's 0.5. And a quarter of a dollar is 25 cents, and so there, a fourth is a quarter, there's a quarter. Now, we're going to calculate this. And we can just use some scrap paper to do this. Let's take 120.5 and 120.5 and a 66.25 and a 66.25, and let's add all this up. Annex a couple of zeros on there. So we have 5, 10, write down the 0, carry the 1. I have 5, 10, 11, 12, 13, 14, 15. Write down the 5, carry the 1. I have 6 and 6 is 12 and 1 is 13. Write down the 3, carry the 1. 6 and 6 is 12, 13, 14, 15, 16, 17. Write down the 7, carry the 1. So it looks like 373.5 feet. Okay? So I'm going to come right over here and I'm going to put P equals 273.5 feet. Okay, it's perimeter. It's not feet squared, it's just feet. Now then, that's to go around at one time. That's to go around at one time. Remember, we're going to put 3 rows. So now I need to take this 373.5 and multiply it by 3, because there's going to be 3 rows. So 3 times 0 is 0. 3 times 5 is 15. Write down the 5, carry the 1. 3 times 3 is 9, and 1 makes 10. Write down the 0, carry the 1. 3 times 7 is 21, and 1 makes 22. Write down the 2, carry the 2. 3 times 3 is 9, and 2 is 11. So I need 1,120.5 feet for 3 rows. Okay? That's what I need. This was my need. Now, let's go see what we bought. He bought 130 boards that were 8.5 feet long. Well, I don't want to add 8.5 up 130 times, so I'm going to take 130 times 8.5, 8.5. Multiplication of decimals. So 5 times 0 is 0. 5 times 3 is 15. Write down the 5, carry the 1. 5 times 1 is 5, plus 1 is 6. Placeholder. 8 times 0 is 0. 8 times 3 is 24. Write down the 4, carry the 2. 8 times 1 is 8, and 2 is 10. Add them up. 0, 5, 10, 1, 1. And I got to put that right there. Okay, so he needed this much, and he bought this much. Compare these two numbers. 1,120.5 is what he needed. He bought 1,105 feet. Did he buy enough? The answer is no. He did not buy enough. Now, if you live out where I do and you're trying to build something, you want to always, when you've got to drive 60 miles to go to town, you want to get what you need when you go there. You don't want to be short supplies. Okay, I hope you enjoyed that horse building arena. And just know that if I got asked to calculate that at my house and I didn't calculate it right and I had to make 2 trips to town, my husband would not be very happy with me. So we work on getting things right from the start. All right, in example 2, we're going to solve a multi-step problem with decimals. 26 2/10 mile marathon is being planned. Now, if you don't know what a marathon is, teachers, I need you to stop, pause the video, and discuss what a marathon is to all your students. They might see that word again sometime, and they need to know what it is. Okay, so I'm assuming you discussed this, and everybody knows that a marathon is a race that you run on foot, and it's a little over 26 miles long. And you would probably ask, well, why is it that length? It has to do with something that happened in Greece many years ago, and it was the distance between 2 towns. And that's how they came up with the length of the marathon. Okay, so let's read this and see if we can understand what they want us to do. Water stations are being set every 2 62/100 miles along the marathon route and at the start line. How many water stations are needed? Okay, so if I understand this right, here's our start. I'm going to draw a little picture here. And then we're going to have a water station. And then we're going to have another water station, and another water station, 1, 2, 3, 4, and one more water station. So that's the start and that's the finish. Okay? And we have a water station here, 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 and here. So that's only 4 divisions, 1, 2, 3, 4 divisions in the total length. Well, this total length is 26 2/10 miles, 26.2. So we want to divide that up equally 4 times, because one of the water stations is right here and no length has been used yet. Okay? So I'm thinking through it my way. Well, right here is where they have said that, 26 and 2/10 divided by 4. So we're going to take 26 and 2/10, we're going to divide that by 4. Now, you've already been working on division of decimals. I'm going to go straight up in my answer. Since this is a whole number right here, I know my decimal is going to be straight up from right here. I start with the first number. Will 4 go into 2? No. So I move my finger over. Will 4 go into 26? Yes. It will go 6 times. 6 fours is 24. Draw a line, subtract, bring down the next number. Okay, will 4 go into 22? I believe so. 4 fours is 16. 4 fives is 20. So 5 is 20. And bring down a 2. And x is 0 and go again. And 4 fives is 20 again with the remainder of 0. So at 6 and 55 hundredths, each one of these links is 6.55. 6.55. 6.55 and 6.55. Okay? Now, teachers, if you would like to pause and talk about, have one of your students read how they went about it and their thinking and discuss that, you may do that. Also, you may pause and do the try it at the bottom, which relates also to this problem, and then come back to me when you're finished. Okay, I'm going to work a few problems with you on this Do You Understand? And before we begin that, let's please look at the key concept. When solving multi-step problems with fractions or decimals, see all these bullets? Decide the steps to use. Well, I'm going to add one more bullet in there, and it's a very important one. Read the problem at least 3 times. Make sure you understand the problem. So we're going to read it the first time just to hear the words and kind of get a general idea. We're going to read it the second time to start thinking about how to solve it. And the third time we're going to underline or highlight the important information and start picking out what we need to use to work the problem. Then we're going to decide what steps to use. We're going to choose the correct operations, whether it's add, subtract, multiply, or divide. We're going to identify the information we need from the problem. We're going to correctly use the information. We're going to calculate it accurately. And then we're going to interpret our solution and check to see if that answer is reasonable. All of that is embedded into here also. But if you can't read, you can't even begin the problem. Number 1, how can you solve problems with rational numbers? How can you solve problems with rational numbers? Okay, so we're going to read first and decide which math rule to apply. Then calculate. Now, if it's a fraction times a fraction, we're going to do top to top, bottom to bottom, cancel if you can. If it's a division of rational numbers, we're going to keep, change, flip. So we're going to read and decide which math rule to apply, and then we're going to calculate. Okay, remember, if I'm writing, you should be writing. Number 2, Megan has 5 1/4 yards of fabric. She plans to use 2/3 of the fabric to make 4 identical backpacks. To find how much fabric she will use to make the backpacks, Megan multiplies 5 1/4 by 2/3. What else does Megan need to do to find out how much fabric she needs for each backpack? All right, let's read it again and start underlining important information. She has 5 1/4 yards total. She plans to use 2/3 of that 5 1/4 to make 4 identical backpacks. She's going to use 2/3 to make 4 backpacks. To find how much fabric she will use to make the backpack, Megan multiplies 5 1/4 by 2/3. Is that correct? Yes, it is, because I'm going to use 2/3 of this. So I need to know what is 2/3 of 5 1/4. So we're going to take 5 1/4 and multiply by 2/3. So we've got to change 5 1/4 from a mixed to an improper. 4 times 5 is 20, plus 1 is 21 over 4. And then we're going to multiply that by 2/3. Okay, we're going to do that operation. Top to top, bottom to bottom, cancel if you can. Well, 3, there's a factor of 3 here and a factor of 3 in 21. So 3 goes into 3 one time and 3 goes to 21 7 times. I also have a factor of 2, and there's a factor of 2 in this 4. So 2 goes into 2 one time, 2 goes into 4 two times. So what's left is 7 times 1, which is 7, and 2 times 1, which is 2. So that's 7 halves. Now put that back in mixed, or 2 goes into 7 3 whole times with a half left over. 7 halves is the same as 3 1/2. Now the question is, that's how much fabric she's going to use. What else does Megan need to do to find out how much fabric she needs for each backpack? This is how much she's going to use total. So how's she going to find out for each backpack? When we start dividing stuff up by each something, it's division. So now she needs to take 3 1/2 and divide it by 4 backpacks. Well, this is a mixed and this is a whole. So we're going to change this mixed to improper, which was 7 halves. And we're going to take this 4 and write it as over 1. So it's 7 halves divided by 4 over 1. And then we have to use the rule for division, which is keep, change, and flip. Okay, so 7 times 1 is 7. 2 times 4 is 8. She needs 7/8 of a yard, not quite a whole yard, for each backpack. Okay? Okay. Number 3, critique reasoning. Each side of a square is 10 1/2 feet. The key word here is square. Square means it's the same length on every side. And the patio is made up of 1 1/2, 1.51 5/10 foot by 1 1/2 foot square stones. So what is the number of stones in the patio? Oh, well, that's going to be fun. Let's draw a picture. Now, you don't have any graph paper, so I'm going to do this with you right here. I have the patio drawn, and let's see if it's 10 1/2. Let's see, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1/2. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1/2. So this is a 10.5 by a 10.5. Okay? And then each one of these stones, these individual stones, is a 1 1/2 by 1 1/2. Okay? So the stones are 1 1/2 by 1 1/2. So if I want to find the area of a stone, I need to multiply these two numbers together. So let's do that. 1 1/2 and 1 1/2. Practice multiplication of our decimals. 5 times 5 is 25. Write down the 5 and carry the 2. 5 times 1 is 5 and 2 is 7. 0. 1 times 5 is 5 and 1 times 1 is 1. That's a 5. 7 and 5 is 12. That's 22. And I have 2 decimal places, so it's 2 and 25 hundredths. 2.25 for each stone. Now, let's find the area of the patio. Oh, has anybody said, I don't remember how to find area? Well, area of the patio, area is equal to length times the width. Area of the stones is a length times the width. We just did a length times the width, and this is feet squared, because feet times feet is feet squared. Let's do the patio. Patio is 10.5 by 10.5. So we got to come down here and do that math. 5 times 5 is 25. Write down the 5, carry the 2. 5 times 0 is 0 plus 2 is 2. And 5 times 1 is 5. Annex a 0. 0 times 5 is 0. 0 times 0 is 0. And 0 times 1 is 0. Annex 2 zeros. 1 times 5 is 5. 1 times 0 is 0. And 1 times 1 is 1. And add everything up. 5 and 2. 5 and 5 is 10. Makes that a 1 and a 1. I got 2 decimal places, so 1, 2 goes right there, and that is feet squared. So, the patio is 110.25 feet squared. The stones are 2.25 feet squared. So now we found the area of each stone, and we found the area of the patio is 110.25 feet squared. There's both of them right there. Now, let's go back to the problem and let's see what questions they're asking. What's the number of stones in the patio? Well, that's easy. We take the total patio area and we're going to divide it by each stone. So we're going to take 110.25 and we're going to divide that by 2.25. Okay? Now, everybody should be able to do this division of decimals. Remember, we can't have decimals out here and do the division. We have to move it to get rid of that. So this has got to be 225. And then that's going to make this 11025 with the decimal being right there. Now, this video is getting a little long, so to save a little time, I'm going to do this with my calculator. You'll have a calculator after Christmas, but not till then. And your answer comes out to be 49. 49. That means 49 stones. And what was the question? Question was, what was the number of stones in the patio? We got 49 stones. And then it says, does it include all the steps needed to solve the problem? What did we do? Here's the area of the patio. Is this the area of a stone? No, it is not. The area of a stone should have been 1.5 times 1.5. Remember, 1.5 times 1.5. They only divided it by 1.5. So they did not. This is incorrect right here. It's an incorrect step. Does it include all the steps? No, it does not. Okay? They should have divided by 2.25 instead of 1.5. And you could just circle that right there. There's where the step is incorrect. Okay. I need for you to do whatever your classroom teacher asks you to do when it comes to your assignment. We've got 3 problems started on this. If I were you, I would continue on right here until your class time runs out. If you get through at this page, then I would go on to page 55 and get as much done as possible. And I'll be back with you tomorrow. We'll do some more of this. Good luck. Talk to you later.